where today we are going to learn how to use matrices to solve systems of equations like this one. And first you have to take the system that you're given and turn it into a matrix equation like this. First we'll make a coefficient matrix like this. See all these coefficients, the 8, 7, 4, negative 9? So that's going to become our first matrix, 8, 7, 4, negative 9. Okay, that is called the coefficient matrix, and I'll label that later. Next, we have the variables, x and y. That's its own matrix. And finally, we have the constant matrix, 5 and the 65. Alright, so what we have here is a matrix equation. And let's always call the coefficient matrix A. We'll call the variable matrix X. And we will call the constant matrix B. Alright, if we agree on that, then when we go to solve these problems, we can do this. So basically, what we start off with is matrix A times matrix X equals matrix B. But what we find is, if we want matrix X, we can get it by doing the inverse of matrix A times matrix B. So this is the key. This is what we're going to be doing over here. So it looks like if I need to find the solution matrix, the variable matrix, I need the inverse of A. I've got B. So let's find the inverse of A. So that's sort of step one, is we need to find A inverse. Okay? Now, but finding A inverse itself has two steps. Because in order to make the inverse, we first need the determinant of A. Okay, in fact, I'll just go ahead and do it like this. The determinant of A, remember, is the down diagonal minus the up diagonal. Alright, so if I want the determinant of A, that's going to be negative 72, alright, the down diagonal, minus 28, because that's the up diagonal. So the determinant is negative 100, alright, we're going to need that later. Now that we've got the determinant, we can go ahead and find the inverse. So the inverse of A is going to be negative 1 over 100. Alright, it's the reciprocal of the determinant times reverse negate. Reverse negate. Yeah, if you've never watched me doing this before, you have no idea what I'm doing. But when you do the inverse matrix, in addition to doing the reciprocal of the determinant, inside of here we have to reverse the down diagonal and negate the up diagonal. That's why I say reverse negate, because it reminds me of the cha-cha slide. So this is going to become, and I feel like using a different color, when I reverse the down diagonal, that'll be negative 9 and 8. If I negate the up diagonal, then this will become negative 4 and negative 7. So this is A inverse. Now normally I would take this 100 and divide all four of these things by it. That's going to make fractions everywhere. So I would recommend saving that for later. For right now, let's consider this entire thing as A inverse, all of it. Alright, the fraction and the reverse negate. So now we can come back over here. We're supposed to be finding the variable matrix, and we're supposed to get that by doing A inverse times B. Well, look, here's A inverse. A inverse is negative 1 over 100, okay, times negative 9, negative 4, negative 7, 8. All right, that's A inverse. And then we also need B. Okay, and B is 5 and 65. Okay, so X equals A inverse B. So X equals, all of this is A inverse, and maybe I can make this a different color. So, and this, it goes together. Oh well. This is A inverse, and this is our B. So all we need to do is multiply these together, but it will be easier if we multiply these matrices together first, and then just divide everything by negative 100 at the end. So let's give that a try. Now looking at these dimensions, this is a 2 by 2 matrix, and this is a 2 by 1 matrix. That means the final result is going to be a 2 by 1 matrix. All right, that's good to know. All right, so as we do this, just know that the final result is going to be in this shape. It's going to be a 2 by 1, where this will be element 1, 1, and this will be element 2, 1, second row, 1 column. And don't forget, really in the front here, we're going to have 1 over negative 100. That's still there. Okay, so all we need to do is find these elements. I think I'll change to another color. Let's do green. Okay, so element 1, 1. That is the first row times the 1 column. So that is going to be negative 9 and negative 7. Okay, first row times the 1 column we've got. So that's 5 and 65. If I multiply this together, that gives you negative 45 and negative 455. If you put these together, that gives you negative 500. Okay, so that is our first element, which is going to go right here. So negative 500. Now we need to find element 2, 1. Okay, so element 2, 1. Alright, that's row 2, column 1. So that means row 2 and then the column. So negative 4, 8 times 5 and the 65. So this time we're going to get negative 20. And then that's 520. If you put that together, that's going to be 500. Okay, so that is our second element. All right, element 2, 1 is 500. Okay, so we're almost done. All that's left is to multiply by this 1 over negative 100, which really means we're just dividing both of these by negative 100. Okay, I feel like I should put this in a box off to the side. Okay, so as we finish this up, negative 500 divided by negative 100, that's going to be 5. And 500 divided by negative 100 is going to be negative 5. Okay? So that means x is 5 and y is negative 5. And that's how it's done. That's how you can use matrices to solve a system of equations. Clearly, we're going to need more practice, but that's the basic idea. Alright, let's move on to number 7. Alright, once again, the first thing we need to do is create a matrix equation. So this is going to be 7 and 5 and 4 and 3. That is the coefficient matrix. And then we'll have x and y. And that's going to equal 14 and 9. Alright, so what we have here is a times x equals b. Alright, so if that is true, I'm just going to put my line right here. Then if a times x equals b, then what we need to find if we want x is we need a inverse times b, and that's what we're going to be doing over here. But once again, first we need to find a inverse. So let's find a inverse over here. Find a inverse. In order to find a inverse though, first we need to find the determinant of a. Determinant of a is going to be the down diagonal minus the up diagonal. So that's going to be 21 minus 20. Alright, which equals 1. So that is my determinant. That's the number I'm going to wind up dividing by everything by later. That's going to make this relatively easy. Now that we have the determinant, we can go ahead and find the inverse. Alright, normally we would do the reciprocal of this, but the reciprocal of 1 is still 1. So we're just doing 1 times the reverse negate matrix. So we have to reverse the down diagonal, so this will become 3 and 7, and negate the up diagonal, so that's going to be -4 and -5. Okay, now because on the previous problem I had a big ugly fraction with 1 over -100. So I didn't multiply because I was going to make a bunch of ugly fractions. It was easier to divide at the end and just divide 2 numbers at the end. But this time it's just a 1, so that's not going to make ugly fractions. So in fact, multiplying by 1 does not change anything. So the A inverse is just going to be the 3, the -5, the -4, and the 7. That is our A inverse. So now we can go ahead and do our A inverse times B. Okay, so we're doing this. X is supposed to equal A inverse, which is 3, -5, -4, and 7, times B, which is 14 and 9. Okay, we're just doing this. X equals A inverse times B. So just to label it up a little bit, this is our A inverse and this is our B. So A inverse times B. Okay, and we know that this is going to form a matrix of this shape, where it's going to be element 1, 1 and element 2, 1. So let's just find those elements one at a time. So let's start with element 1, 1. Element 1, 1, that's going to be row 1, so 3, -5, times column 1. So that's our 14 and our 9. Alright, so that's going to be 42 and -45, we're multiplying, and when we add those together, that's going to give us -3. Okay, so that is our first element. And you know what, I think I'm just going to keep going and find the other element. So let's go ahead and do element 2, 1. So that's going to be row 2 times column 1. So that's going to be negative 4 times 7, and our 14 and our 9. So that is going to give us negative 56 and 63, which is 7. So these are the two elements. So we have our negative 3 and our 7. Now remember, this is the variable matrix X. This is matrix X. And matrix X is in the form X, Y, like this. So that's how we know that X is equal to negative 3 and Y is equal to 7. Alright, so we solved another system using matrices. Let us move on to number 8. Alright, once again, to solve this system, we will write a matrix equation. So this would be 3 and 5 and negative 7 and negative 8. Variable matrix X and Y. Constant matrix 25 and 27. Again, let's call this matrix A and matrix X and matrix B. So, what we need is, if I want to find matrix X, I'm going to be doing A inverse times B. So, let's find A inverse. But finding A inverse is a two-step process. First, I need to find the determinant of A, which is the down diagonal minus the up diagonal. So that's going to be negative 24 minus negative 35. Down diagonal minus the up diagonal. Okay, now negative 24 minus negative 35 is the same thing as negative 24 plus 35. So we're going to get 11. Okay, so the determinant of matrix A is 11. So this is the thing we'll be dividing by later. Dividing by 11. Now, now that we have the determinant, we can go ahead and find the inverse. A inverse is going to be, to show that we're dividing by 11, we'll put the reciprocal 1 over 11 in front of our reverse negate matrix. So reverse the down diagonal, so that's going to be negative 8, 3, and negate the up diagonal, so that's going to be negative 5, positive 7. Alright, reverse negate. Okay, so this is A inverse. Okay, all of this mess is A inverse, including the fraction. Now I could sit here and multiply that fraction by everything and get a bunch of fractions, but who wants to spend the rest of the problem dealing with ugly fractions? So instead, let's just keep it, all of it. So now let's proceed with the rest of the problem. Alright, so we just said if I want to find X, I need to do A inverse times B. Well, this is A inverse. In fact, maybe I can copy it. It's taking that mess with it. Okay, this is A inverse. Trying to cheat. Alright, so there's the A inverse that I just copied over from the left, and we're supposed to do A inverse times B. So here comes B. B is this 25 and 27. Alright, so it's A inverse times B. So rather than dealing with this dividing by 11 business, I would instead, I'd multiply these two matrices together first. Alright, so for right now, let's just keep the 1 over 11 out there. If you do this, you know you're going to wind up getting a 2 by 1 matrix. So I'm talking about element 1, 1 and element 2, 1. So I just need to find those elements. So here I go. So element 1, 1 is going to be row 1 times column 1. So row 1, so that's -8, 7 times column 1, so that's 25, 27. So -8 times 25, that's -200, and 7 times 27, that's 189. Combining these like terms, I get -11. Okay, so that is our first element, which I can go ahead and put in there. My computer doesn't run too slow. So I have my -11. So now I need to find the second element of element 2. You know what, maybe I should show this as a separate. Matrix all together. Okay, so I found the first element. Now I'm going for the second element. So element 2, 1. That's second row, first column. Second row is my -5, 3. And of course the first column is my 25, 27. So -5 times 25 is -125. 3 times 27 is 81. So that's going to give us -44. Whoa, that doesn't look right. -44. So that'll be -44 right there. Now, don't forget to do this last little step right here. Basically, multiplying by 1 over 11, we're dividing by 11 is what's happening. So divide both of these by 11. Okay, so if I do that, then I'm getting that matrix X is -1 and -4. Alright, just dividing both of these by 11, which means that X is -1 and Y is -4. And once again, that is how you use matrices to solve a system of equations. Alright, let's move on to the back. Alright, this time we do not get to avoid the ugly fractions. Luckily, we have our trusty TI-30 XS Multiview at our side to help us out. Alright, let's do number 10 and deal with these ugly fractions. Well, it's going to start off the same as before. We need to turn this into a matrix equation. So this is going to be 3, -3, and 5. And this is going to be 5, 6, and -2. Now be careful on this third equation. One of the variables are missing. We have X, we have Y, we're missing Z. So the 7 from the X, the 5 from the Y, and put a 0 to represent the Z, 0Z. And okay, fine, the variable equation. Now we'll have 3 variables, X, Y, and Z. And finally the constant matrix, which will be 13, 10, and 18. It's not writing. Alright, and once again we will call this matrix A, the coefficient matrix, and this will be matrix X for the variables, and we'll use matrix B for the constant matrix. Now, like we saw when the matrices were smaller, if I want to have the solution matrix X, that's going to be A inverse times matrix B. That's how I can sort of get this matrix by itself, A inverse times B. Now, well, here's the good news, because normally this is the part where we sit around trying to create the inverse matrix. But we haven't learned how to find the inverse of a 3 by 3 matrix, and doing that by hand is not going to be part of our curriculum. I will teach you how to do it on a graphing calculator, but not today. For today, I'm just going to give it to you. Alright, so here where I say, hint, this is the inverse of the coefficient matrix. A is the coefficient matrix because it came from all of these coefficients. So I am giving you A inverse. Okay, now of course, X should equal A inverse times B. So if I want to find X, I need to do A inverse times B. So I'm just going to write matrix B right here. Alright, because I'm trying to do A inverse times B. Matrix B was this, remember? 13, 10, and 18. So all I have to do is multiply this ugly matrix, A inverse times B, and that should give me the answer. Okay? Now, just remember in the back of your mind that X should be a 3 by 1 matrix when we're done. So we're looking for something of the form element 1, 1, element 2, 1, and element 3, 1. Okay? And just in case you forgot, the reason why I know this is because this is a 3 by 3 matrix, and this is a 3 by 1 matrix. So the result when I multiply comes from the outer dimensions. So that's how I knew it would be a 3 by 1 matrix like this. So all I need to do is find all these elements, these 3 elements. Okay? So, and you know how to do that. Let me leave myself as much room as I possibly can. Okay, so if I want to find, and I'm just going to kind of draw a line right here. Alright, if I want to find element 1, 1, that's going to be row 1 times column 1. Okay, I'm talking about row 1. Okay, and then times the column here. So it's really going to be like this. I'm talking about negative 10 over 13, negative 25 over 13, and 24 over 13. Okay, that is row 1. Alright, isn't that ugly? And then column 1 is the 13, 10, 18. So 13, 10, 18. Okay, so when I multiply this stuff together, remember this 13 is like 13 over 1. So I really am just going to wind up multiplying the 13 times the 10. So this is going to give me negative, see, 13 times 10 is 130. So it's negative 130 over 13. Oh, look, another 10. So that's going to be negative 250 over 13. 24 times 18. Let's check that out. Okay, that's 432. Okay, so I've got 432 over 13. Alright, now you remember what we're supposed to do. We're supposed to take all of these and add them up, and that should give us our first element. Okay? So let's just use a calculator to help us out. So we've got negative 130 over 13. Notice how every time I say over, I can hit this N over D button and it just does it. Okay, you don't really have to hit the N over D button first. And I'll do plus. Now I've got negative 250 over 13. Alright, I have to use my arrow key to get it out of the denominator. Plus 432 over 13. Alright, put all that together, you get 4. All this stuff boils down to just 4. So 4 is our first element. Okay, so that means, okay. Alright, our first element is 4. Now we just got to do that 2 more times. Alright, so let's try it again. I think I'll change colors this time, so I don't get mixed up with the other stuff. So now I'm doing element 2, 1. So that means I'm now looking at row 2 and column 1. So here's row 2 that I'm dealing with. So here we go. Row 2. We have 14 over 13. And we've got 35 over 13. And we've got negative 31 over 13. Okay, so that's row 2. Now, of course, column 1 is our good old 13 and 10 and 18. Alright, if I multiply this stuff together, 14 times 13, I don't actually know that off the top of my head. 14 times 13, that's 182. So this is giving me 182 over 13. I can multiply by 10 all day, just add that 0. So that's 350 over 13. Negative 31 times 18. Don't know that off the top of my head. Negative 31 times 18. So that is negative 558. So that's negative 558 over 13. So all I have to do is add this all up, and I'll get my second element. Okay, so here we go. 182 over 13. 182 over 13. Get out of the denominator. Plus 350 over 13. Get out of the denominator. Plus negative 558 over 13. Negative 2. All that stuff, at the end of the day, it boils down to negative 2. So that gives us our second element. By the way, the answers will not always be nice integers like this. Sometimes even the answers themselves will be ugly fractions, but not today. Alright, let's do this one more time. See if I can squeeze it in. I think I ought to do green now. Okay, one more time. So I'm doing element 3, 1. So I need to do row 3 now. Alright, so I'm doing row 3 times column 1. So that means I've got 17 over 13 and 36 over 13 and negative 33 over 13. Okay, that is row 1 times column 1, 13, 10, and 18. Hmm, 17 times 13. Let's check it out. 17 times 13. That's 221. So I've got 221 over 13. 36 times 10, so that's 360 over 13. 18 times 33. Alright, that's 594. So that's negative 594 over 13. Alright, so I'm supposed to add all these up, and that should give me my final element. That will be right there. Back to the TI-30XS multiview. So 221 over 13. Get out of the denominator. Plus 360 over 13. Get out of the denominator. Plus negative 594 over 13 equals negative 1. Alright, so that gives us our third and final element. Alright, and that puts us in a position to know what the final answer is. Since our variable matrix, alright, we just found matrix X, but matrix X was X, Y, and Z in that order. So that means, of course, that this is X, this is Y, and this is Z. So I'll just record that at the bottom of this problem. And this time I think I'll put it as an ordered pair. Now I'll do it both ways. So X equals 4, Y equals negative 2, and Z equals negative 1, which I could write as an ordered triple: 4 times negative 2 times negative 1. Alright, there you go. Alright, and this is the last one. So here we go, one more time. Set up our system. So this is going to be 4, 1, 1. And this will be 8, negative 4, and negative 7. Now, this time I'm missing the X term. I have my Y and my Z. So I put a 0 here, 0X, 5Y, negative 9Z. Be careful of where your zeros go. And then I'll have my variable matrix, X, Y, Z. And that should be equal to my constant matrix, 1, 2, 3. Okay, so this is A, matrix A, this is matrix X, and this is matrix B. If we want to find matrix X, it should equal A inverse times B. Alright, now as we learned from the last problem, this is the inverse coefficient matrix. That means this is A inverse. And so if I want to find X, I need to do A inverse times B. So that's why I put B over here, 1, 2, 3. and that's going to be my matrix B. So I just need to start multiplying all these things together. So I know that it's going to be of the form element 1, 1, element 2, 1, and element 3, 1. So all I have to do is find these three elements. Unfortunately, I have to go teach class, so I will have to finish this later, which means the video will probably be up late. Oh well, what are you gonna do? I had a meeting. So let's just take it one at a time. We need to find these three elements. So let's start with element 1, 1. That means we need row 1 times column 1. Now when I say row 1, I'm talking about this ugly mess right here. That is row 1. And of course column 1 is just matrix B itself. So okay, there's no way around it. This is going to be a little bit ugly, but that's okay. Don't be scared. So this is going to be 71 over 396, and then 7 over 198, and then negative 1 over 132. Okay, that is row 1. And that has to be multiplied times column 1, which is just 1, 2, 3. 1, 2, 3. If we do this, obviously multiplying by 1 doesn't change anything, so that stays 71 over 396. The 2 is just going to get multiplied by the 7 because it's like 2 over 1. So that's going to be 14 over 198. And then the 3 is just going to wind up multiplying the negative 1. So that's going to be negative 3 over 132. So we are supposed to add up all this stuff and see what we get. So let's use our TI-30XS multi-view. So here I go. 71 over 396. 71 over 396. Get out of the denominator. Plus 14 over 198. Get out of the denominator. Plus negative 3 over 132. That gives us 5 over 22. I don't remember that being the answer. Let me see if I can find my mistake. Alright, I double checked my answer and I found that I was right. It just is a fraction. So it's 5 over 22. So let that be a lesson to you. These answers are not necessarily going to be nice, even numbers. Sometimes there will be ugly fractions. So 5 over 22 is the first value. Alright, and if they're going to be ugly fractions, then I might need more room in this matrix. Okay, let's keep going and find element 2, 1. Okay, so here I go. Element 2, 1. That's going to be row 2 times column 1. Okay, so now we're dealing with row 2. So here we go. That's 2 over 11 and negative 1 over 11 and 1 over 11. That's row 2. Alright, of course column 1 is 1, 2, 3. That makes this 2 over 11, negative 2 over 11, and 3 over 11. and then we're supposed to add these all up. Okay, so 2 over 11 plus negative 2 over, okay, that's silly of me. I'm sitting here doing this on a calculator, but obviously positive 2 elevenths and negative 2 elevenths, they just cancel each other out and make 0. So the answer is just going to be 3 over 11. Silly Burton. Alright, positive 2 elevenths, negative 2 elevenths, they cancel each other out. So it'll just be 3 over 11. Okay, now let's find that last element. Alright, so this will be element element 3, 1. Okay, so that's going to be row 3 times column 1. So row 3 is this row. Alright, so row 3, here we go. So that's going to be 10 over 99 and negative 5 over 99 and negative 2 over 33. Alright, and that's going to be multiplied by 1, 2, and 3. Okay, because that's column 1. So that is going to give us 10 over 99, negative 10. Alright, 5 times, negative 5 times 2 is negative 10 over 99, and negative 6 over 33. I'm supposed to add these all up again, but look, once again, positive 10 99ths and negative 10 99ths, those are going to cancel each other out. So I'm just going to have negative 6 over 33, but this will reduce. Both of these are divisible by 3, so this will be negative 2 over 11, just because you reduce it. See? Negative 2 over 11. Okay, so that is the third and final. Alright, so these are the 3 values. So that means, in the end, we have this. X equals 5 over 22. Y equals 3 elevenths. And Z is equal to negative 2 elevenths. So this is the final answer. I could also write the answer as an ordered pair, as 5 over 22, comma, 3 over 11, comma, negative 2 over 11. Either way. Alright, that is it. That is how you use matrices to find the solution to a system of equations. I will see you on the next video.